Restoring a Bing Clockwork Train. This is part 5, repairing the paintwork and making some new buffer stocks. This job is much more of an art than a science, and it's definitely a different use of the calibrated eye. I'm going to try first of all using 3 colours. One is LMS Crimson Lake, the other one is Humbrol Matte Red, and the third one is Humbrol Matte Black. Many years ago when I was at school, and that is a long time ago, I was given a colour blindness test and I was told that I was red-green colourblind. Well, I think they were wrong. This blue paint looks fine to me. I need to mix a colour that matches the existing paintwork to touch in the damaged parts. And the first attempt is not good, it's far too bright. So I added a little bit more matte black and tried again. This time it would appear to be quite a good match. So I'm going to repaint the entire front part of the engine. But first of all, I'm just making sure that the colour's right. So back onto the colour blindness test story. Everyone in the class, one at a time, was asked to look at these books that they brought in. The images in the books were made up of lots of different coloured dots, and somehow there was supposed to be a picture underneath all this. Well, I just didn't get it, and the pictures that I saw were very rudimentary. But after this test, I was informed that I would never be able to be an engine driver, and nor would I ever be able to work in the electronics industry, because I wouldn't be able to see the resistor colour codes. So I think they got it wrong. I've been an engine driver for quite a long time, albeit with miniature engines. Oh yeah, and I forgot, initially I went to college to train as an electronics engineer. But, hey-ho, it's now 2018, and I'm applying my colour blindness to match this paint. I repainted the front part above the buffer beam because it's very visible, but most of the job is just repairing the existing paintwork. Don't write in just yet. This paint is very shiny because it's wet, but as the mixture is largely made up of Humbrol Matte Black and Humbrol Red with a bit of Crimson Lake in it, when it dries it should dry back to a matte finish. I think it's time to repaint the roof, but before I do that, I'm going to repaint this flap that swings out and covers the gap between the engine and the tender. No colour matching required on this. This is Humbrol Matte Black, and I stirred the tin of paint thoroughly to make sure that the flatting agent in the paint was evenly mixed. That's the bottom part done, not forgetting the edge, and now it's the top part. Once again, when this paint dries it will go dull to match the rest of the engine. And while I'm in matte black mode, I'm going to paint the footsteps at each side of the engine. Probably these were not black in the first place, but someone in the past, many years ago by the look of it, went over parts of this engine with black paint. The black paint that was used by the person who painted the engine was gloss black, but with age it's gone dull. So now I'm going to paint the roof, but I'm using matte black. Also, the matte black paint in this tin is quite thick. It needs thinning really, but I don't want the freshly painted look. I want the, "Look Dad, I've just painted my engine, what do you think?" look. Yes son, that's very good for a 5-year-old. Well done, you've completely devalued the engine and made a thorough mess of it. And the next time anyone comes to the door collecting for Dr. Bernardo's, I'm going to give them you. So all these years later, I'm duplicating the bad paint job. And once again, this is matte paint, so when it dries it should look okay. And here is a picture of the paint drying. It's not fully dried, but eventually it will match the existing paintwork. When I first bought this clockwork engine, it didn't have a chimney, and the front part that I'd been repairing was really badly damaged. And there was only the remains of this one buffer stock on the entire engine. So what I'm going to do here is measure it up. I need to make this thread a little bit longer, because owing to the extensive repairs on the front buffer beam, this buffer beam is a bit thicker than it was originally. I think I'll make the threaded part just over 1/4 of an inch long. This old clockwork engine is of German origin, so the parts are metric, and in this clip I'm selecting a 4.8mm drill which fits perfectly in the existing buffer stock. What I'm doing at the moment is not good engineering practice. With the drill bit pushed into the existing buffer stock, I'm marking it with a felt tip pen. Now it's over to the lathe, and I'm using my Boxford lathe for this job. I've put a piece of brass bar in the chuck and it's 3/8 of an inch in diameter. I need to reduce it to match this buffer stock. I take a test cut and micrometer that, and it's quite a long way to go yet. The lathe tool is squealing a bit because, to be perfectly honest, it's not very sharp. But as this part's going to be painted, I need the finish to be rough. I don't want it to be smooth. The roughness of the finish will be a good key for the paint. In no time at all, the brass bar is exactly the same diameter as the original buffer stock. So I'm centre drilling the end of it using a small centre drill, followed by the metric twist drill, which is 4.8mm. The depth of this hole will be exactly the same on all the buffer stocks that I make, because the drill's only going in as far as the felt tip pen mark. On the original buffer stock, the ends are rounded. I'm sure this was done by some sort of a form tool. No CNC in those days, but I'm just using a file to round it off. And don't forget, health and safety, when you're using a file to file in the lathe, make sure it has a handle. Before finally parting off the first of the buffer stock blanks, I'm drilling down the centre of it using a 1/8 drill. And this 1/8 hole will be where the bolt goes through to hold the buffer head in position. And in this clip, new buffer stock number 1 is parted off. And now the mass production continues, but please don't turn off, because I'm not going to show the making of every one of these buffer stocks, as the operation is identical for all of them. And here they are, 4 buffer stocks in my hand. Now I need to cut the thread on the other end of the new buffer stocks. I'm micrometering the old one, so I know exactly how much metal to remove from the other end of the buffer stock, and I'm using a parting tool for this. Please note, it's not a good idea to use a parting tool for general turning, but I do it frequently, it saves time. But you must be aware that if you use a carbide tip parting tool, don't do this because the tip will fall off. You will also note in the previous clip, I removed the parting tool before threading the end of the piece. To cut the thread on the end of the buffer stock, I'm using my homemade tailstock die holder. It's nothing more than a simple adapter that fits into the end of standard die holders, but it works for me. Here's the end product, not a lot of work, very simple to make, a set of 4 identical buffer stocks. And here are 2 of them mounted in the front buffer beam. The other 2 are for the back of the tender. And look at this is a factory original mistake. I was quite surprised when I saw this. Obviously one of these holes was punched in the wrong place and then re-punched in the right place. But when I do a test fit of the other 2 new buffer stocks, as you can see, the buffer stock covers the error. I've been making some crude but very effective modifications in my workshop to create a bit more space. I've created an extension to the workbench to hold my Burgess bandsaw and the Proxxon gear that I bought. And I've got more space in the workshop because underneath this assembly there's room for some tooling. While I was making the buffer stocks, the paint on the engine had dried, and I think that's turned out quite well. It's a good match. Not perfect, but things in life seldom are. And that's it for this episode. Thanks for watching, and I hope you found it useful.